This lesson is on solving quadratics by using factoring. So we're going to use the skills we learned by factoring the trinomials and binomials, and we're going to put it in the context of how we solve a quadratic equation. So the first thing I want to do is outline for you what's called the zero product property. This is the cornerstone of what we use for solving by factoring. And the idea is if we've got two things that multiply together to equal zero. Okay, so you've got two, usually we'll have two parentheses that equal zero. That means that the two things individually, one of them has to equal zero. Either A has to equal zero or B has to equal zero. So when we solve, it gives us two options or two possibilities for what the solution could be. So using that zero product property, we're going to first of all factor what are either a trinomial or binomial, and then we'll solve it. So just as a reminder for factoring this one, because the leading coefficient is equal to 1, I'm going to use my x and x, and then I'm looking for two numbers that multiply together give me negative 45 and add together give me negative 4. Well, if you think about my options, I've got 45 times 1, one of them has to be negative, 15 times 3, one of them has to be negative. Those don't give me negative 4. But then 9 and 5, those are 4 apart. So if I make 9 negative and 5 positive, that will give me 45. And then if I add them, I get the negative 4. So that's what I'm thinking through mentally as I do that. And so the process then just gives me x minus 9 and x plus 5. So when we do a problem like this, our first step is to factor it. So we just did that. X minus 9 times x plus 5 equals 0. Now when two things multiply to equal 0, one of them has to equal 0. So we're going to solve for both of them because that will give us two things that will be an answer to that original. So I take this one and I set it equal to 0. Add 9 to both sides, you get x equal to 9. And this one, set it equal to 0. Subtract 5 from both sides, and you get x equal to negative 5. So my two answers for this are x equals 9 and x equals negative 5. All right, let's try the next one here. Notice that this one is a binomial, so it's two terms. First, though, you got to think about, is there a GCF? I didn't have a GCF here, but here I do. I've got a common factor of 5 in both of them. So take out the 5, and when I take a 5 out of the 45, I end up with 9. Now, this is a binomial middle term. The B term, bx in the middle, has disappeared because it's 0x, and the only way for that to happen is if we have two squares. And remember what you do is you make this x and x for x squared for that. Now the 9, we're going to make 3 and 3. It's 3 squared is equal to 9. And you make one a minus and one a plus. Doesn't matter which one comes first, but you have to have one minus and one plus. That way, if I were to multiply it through, the middle terms plus 3x minus 3x get rid of each other, so there's no middle term, a 0x. Well, we're going to do the same thing for this. When it's equal to 0, we're going to factor it, so we get 5 times, it factors into x minus 3, x plus 3. So we're going to take advantage of the work we have here. Now the zero product property tells me when I have things multiplied, one of them has to equal 0 to zero it out. Well, we know that this cannot equal 0. 5 cannot equal 0, so don't even consider that one. It doesn't have a variable with it. So the constant that you factor out, not part of the solution because it doesn't have an x. But the ones with an x, we set them equal to 0. Add 3 to both sides, and you get x equals 3. This one, make x plus 3 equals 0. Subtract 3 from both sides, and you get 3 and negative 3 as your solutions for that quadratic. Let's try the next one. This one looks a little more complicated. It's a trinomial, but notice we do have a common factor. You can take a 6 out of every term. There's no x to take out, Let's take out a 6 first. So I've got x squared plus 10x plus 6 goes into 126 21 times. Now we want to factor this. Since now that in the parentheses the leading coefficient is equal to 1, I'm going to put 2 parentheses. I'm going to split the x squared into x and x. And now I want two numbers that multiply to give me 21, add together to give me 10. Well, 21 would be 21 times 1, or 7 times 3. 7 plus 3 is also equal to 10, so that would give me plus 7 and plus 3 for it. It could be 3 and 7 instead. It doesn't matter which order you have it in. So let's look at this one. First step, and I'm going to put a little note here, you got to get 0 on one side. So notice that this one, okay, that has negative 126, so I'm going to add 126 to both sides. So we get 6x squared plus 60x plus 126 equals 0. Factor out the 6. I'm going to just go through the steps again. Plus 10x plus 21 equals 0. And now you use your factorization. So this would be x plus 7, x plus 3 equals 0. Remember that constant in front? You can't set it equal to 0 because it's a number that's not equal to 0. It doesn't have a variable. You don't worry about it in the solution. But these you do. You set x plus 7 equal to 0. Subtract 7 and you get x equals negative 7. This one you put x plus 3 equal to 0. Subtract 3 from both sides and you get x equal to negative 3. So I've got these two solutions for my quadratic. All right, so you see when you're factoring, you just leave the factorization. But once the equal sign shows up, we're going to solve. So when there's no equal sign in the problem, just leave it in factored form. But once that equal sign shows up, let's get that final answer of what x's give me an answer to the problem. All right, this one here, look for a GCF. There is no GCF, nothing goes into all three of them. So now we're going to have to use our pattern for the advanced pattern. When the leading coefficient is not equal to 1, I'm going to use the box method here. You could use the X method as well. It's your choice as to which one you prefer. So the box method here, I'm going to put in the first box here 10x squared, and in the last one I'm going to put negative 3. Now I can separate out 10x squared. I can make it 10x and x, or I can make it equal to 5x and 2x. Okay, so let's try 10x and x. If I do that, then I can, for negative 3, I'm going to have, let's try negative 3 and plus 1. So x times negative 3 is negative 3x. 1 times 10x is 10x. Okay, so notice that looks close. It looks like 10x plus 3x, but that's a negative 3x. And so these two do not add up to that negative 13x. They add up to just 7x. So you could switch them. You could flip-flop them and put 10x squared here. And you could put a negative 3 here. I'm going to try 10x and x again. And now I'm going to flip-flop. I'm going to put a plus 1 here and a minus 3 down here. X times 1 is 1x. 10x times negative 3 is negative 30x. Ooh, that's way too, that's negative 29x for that. So that one doesn't work either. So let's try one more here. So we're going to do 5x and 2x instead. Let's try 5x times 2x gives me that 10x squared. Now for the negative 3, what I can do is I can make it a positive 1 and a negative 3 here. Try that out for the my negative 3. 2x times 1 gives me 2x. Negative 3 times 5x is negative 15x. Notice when I add 2x to the negative 15x, that does give me the, it does give me what I'm looking for. It does give me that negative 13x in the middle. So this one does work, so my factorization is 5x plus 1 times 2x minus 3. That's going to equal, and so that's my factorization. No equal sign, so we just leave it with the factorization. All right, now we're going to do the next one where we're solving. This one we're going to come up with answers to it. So I'm going to take this, I'm going to first of all get 0 on one side. That's by subtracting 3 from both sides. Now I'm going to, if I've done this factorization here, I've got my factorization for it as 5x plus 1 and 2x minus 3. Okay, and that's the box method I used over here. That's the one that works. And so now when I take this, two things multiplied equals 0, we got to solve them both separately equal to 0. So set each of them equal to 0. Now solve, I'm going to subtract 1 from both sides. So we get 5x equal to negative 1. I'm going to divide both sides by 5, and I get x equal to negative 1/5. This one I'm going to add 3 to both sides. And I get 2x equal to 3. Now I'm going to divide both sides by 2, and I get x equal to 3/2. So here are my two answers to this trinomial equal to 0. So we're using factoring to solve a quadratic, and the way you do it is you factor the quadratic and then take each of the factors that have variables in them, set them equal to 0, solve them each individually, and then you get your final answer.